Good morning. I am Neha from MSc Chemistry. Isopoly and heteropoly acid. Polyacid. Simply, polyacid may be defined as the condensed or polymerized form of weak acid of amphoteric metal like vanadium, niobium, chromium, or tungsten in the plus 5 and 6 oxidation state. Polysalt. The anion of polyacid contains several molecules of the acid anhydride and the corresponding salt are called polysalt. Isopolyacid. Isopolyacid contain only one metal along with the hydrogen and oxygen. Heteropolyacid contain two elements other than hydrogen and oxygen. Polymerization of chromate ion 2H2CrO4, it gives H2Cr2O7, 3H2Cr O4, it gives H2Cr3O10, 4H2Cr O4, it gives H2Cr4O13. The structure of Cr4 2 negative, the structure of Cr2O7 2 negative, the structure of Cr3O10 2 negative. The trichromate ions can be crystallized as their alkali metal salt only form strongly acidic solution and no polymerization beyond the tetrameric entity is observed. The CrO-Cr bond angle of all polychromate is approximately 120. Isopolyacid and so Isopolyacid and salts of molybdenum and tungsten. When molybdenum trioxide is dissolved in highly basic aqueous solution of NaOH or KOH, molybdate ion gives tetrahedral geometry. MoO3 plus 2 NaOH, it gives MoO4 plus water. The structure of MoO4, when the pH of the solution is lowered down, the protonation of molybdate ions start, followed by the condensation yielding the first major polyanion. MoO4 2 negative plus hydronium ion, it gives HOMoO3 negative plus water. HO MoO3 plus hydronium ion plus water, it gives MoOH6. Although the entropy of the second reaction is negative, yet it is fast as the first reaction, which may be attributed to the large negative enthalpy for the second reaction, compensating the entropy loss. The complete reaction giving different isopoly molybdate 7 MoO4 2 negative plus 8 H positive, it gives MO7O24 whole 6 negative plus 4 water molecules. 8 MoO42 negative plus 12 H positive, it gives MO826 4 negative plus 6 water molecule. Heptamolybdate or paramolybdate is the first stable form of isopoly molybdate. It is worth mentioning that the condensation process from MoO42 negative to MO7 to MO24 4 negative, the coordination of the molybdenum ion change from 4 to 6 and the building block unit of the polyhedral entity becomes MO6 octahedron. Dimolybdate. The general formula of the dimolybdate system is M2O2MoO3 dot XH2 and are observed in the pH range 5 to 6. Na2MO7 is not stable, hence dimolybdate system do not contain MoO7 2 negative. The structure of dimolybdate. Heptamolybdate. The general formula for the paramolybdate is M6MO7O24, where M represents Na, K or NH4 and MO7O24 is quite stable and contain discrete MO7O24 6 negative ion. The structure of heptamolybdate ion. Octamolybdate. The general formula for the octamolybdate is M4MO824, where M represents Na, K or NH4. M4MO8O26 is quite stable and contains distinct MO8O26 4 negative ions. These molybdate can be synthesized by adding stoichiometric amount of MO3 in paramolybdate solution. The structure of octamolybdates. The decamolybdates are obtained as NH4 8 M90O34 and the corresponding molybdate ions MO10O34 are found to have one tetrahedral unit attached at the corner. MO36 polymolybdate, the largest polymolybdate under non-reducing condition till now recent times, is MO36O11 O112 H2O 16 whole के ऊपर 8 negative can be synthesized at the pH of 1.8. 36 MO O4 2 negative plus 64 H positive. It is MO coordination compound of MO 36 O112 whole 8 negative plus 32 H2O. When tungsten trioxide is dissolved in highly basic aqueous solution of NaOH or KOH, tungstate ion with tetrahedral geometry are formed. WO3 plus 2 NaOH. It gives Na2WO4 plus water. These normal tungstate Na2WO4 containing discrete WO4 2 negative unit can be easily crystallized out of the aqueous solution. The normal tungstate of other metal can be synthesized from sodium tungstate via double decomposition. When the pH of the solution is lowered down in the range 9 to 5, the protonation of tungstate ion starts, followed by the condensation yielding the W7O24 6 negative. The whole process of condensation is given by WO4 2 negative plus hydronium ion. It gives HOWO3 negative plus water. HOWO3 whole negative plus hydronium ion. It gives WOH6. Paratungstate A. The general formula for paratungstate A is M6W7O24, where M is normally Na, K or NH4 and contains discrete W7O24 6 minus ions. The edge connection of 7 ideal WO6 octahedron in paratungstate A ions can be visualized in terms of one front and one rear unit. The one front unit the rear unit is the whole structure of paratungstate A is paratungstate B. The paratungstate B is derived as the alkali metal source of domeric anions H2W12O42 2 negative from the acidification of normal tungstate aqueous solution. Upward unit, downward unit, heteropoly, acid and salts of molybdenum and tungsten. The major application of heteropolyanions is in the petrochemical industry, where they are used as a catalyst, as flame retardants, and as precipitant for dyes. 1:12 tetrahedral heteroatom. The general formula for these types of heteropolyanions is X n positive M12O48 minus n, where M is molybdenum or tungsten and X represents the heteroatom, which is generally phosphorus, silicon, arsenic, germanium or titanium. The small heteroatom is present in the inner tetrahedral cavity of the polyanion, hence is surrounded by 6 oxygen atoms of different MO6 octahedron units. 2:18 tetrahedral heteroatom. The general formula for these types of heteropolyanions X2 5 positive M18O62 6 negative, where M is molybdenum or tungsten and X represent the heteroatom, which is generally phosphorus or arsenic. The labeling of this category of polyanion is justified by the basis of number ratio of heteropolyatom to the parent atom, which is 2 to 18, 1 to 16 octahedral heteroatom. The general formula for this type of heteropolyanions is Xn positive M6O24 12 minus N, where M is molybdenum or tungsten or X represent the heteroatom, which is generally technetium, cobalt or aluminium. 1:12 isohedral heteroatom. The German formula for this type of heteropolyanions is X N positive M12O42 12 minus N, where M is molybdenum or tungsten and Y represent the heteroatom, which is generally cerium, thorium or uranium. The labeling of this category of the labeling of this category of polyanions is justified on the basis of number ratio of the heteroatom to the parent atom, which is 1 to the 12.